Hello there teachers, welcome to the first video of the teaching methods series. In this video we'll explore ways to use the factor theorem to factorize the quadratic trinomials, and of course they do represent quadratic functions. Okay, hope you're ready, let's go for it. So we know that the general format of a quadratic function is as follows: ax squared plus bx plus c. Okay, and we know that the factors of this quadratic trinomial are actually linear functions, right? So if we just write it just using variables, we will write it as dx plus e fx plus g. Okay, the binomial multiplied by another binomial. Okay, so that is generally what we get when you do factorize a quadratic trinomial. So the factor theorem, how does this come in? The factor theorem says if ax plus b is a factor of some function f, can be any function, but for the purpose of this discussion we'll take f as a quadratic function, then f of negative b over a will be equal to 0. Okay, so where does this negative b over a come in? We have it as ax plus b equal to 0. When you solve for x here, we have x equal to negative b over a. That is what comes in there. All right, so this is really introducing the relationship between the process of factorization and using the formal theorem, the factor theorem, to explain where we're coming from in terms of what we're doing. Okay, so that is the intro. Let us go to case 1 now as our first example to showcase how we apply this. Right, so this is case 1, and we're going to look at where the coefficient of x squared is 1. What is x squared? It is the leading term. And on the right hand side here, I'm just helping us to refer to the factor theorem. The factor theorem talks about this as the leading term, and b is your constant. Okay, and I want you to look at the sign change from the factor to the solution of x, and from the solution of x to the factor. The sign change must happen there because you end up transposing the constant to solve for x. Okay, what is our leading term here? It's x squared. What is our constant? It's positive 2. That is our constant term. Okay, so what are we going to explore? We're going to explore the following. 2 divided by 1, negative 2 divided by 1. So in other words, it is testing the ratio of your constant divided by the coefficient of the leading term. Constant divided by the coefficient of the leading term. So plus or minus 2 over 1, right? You're going to also test what? Plus or minus 1 over 1. Okay, so this gives you plus or minus 2, and this gives you plus or minus 1. Okay, well, 2 is a prime number, it has only 2 factors. So you're going to test positive 2, sub it into there, and see if you can generate a 0. Test negative 2, sub it into there, and see if you can generate a 0. Do the same thing for plus and minus 1. So if x is equal to 2, definitely this will not give us 0, right? So x squared plus 3x plus 2 is definitely not equal to 0. Okay, so therefore x minus 2 is what? Not a factor. Okay, so we rule out this one where we have x minus 2. Now, if x is equal to negative 2, what's going to happen? If we sub in negative 2 here, are we going to get 0? Yes. Negative 2 squared gives us a 4, right? And 3 times negative 2 gives us minus 6 plus 2, that will be a 0, right? That is equal to 0, and therefore x plus 2, okay? X plus 2 is a factor. We get the sign change here, the sign change that I spoke about. Okay, so what we can then do is to write x squared plus 3x plus 2 is equal to x plus 2. The other factor can be obtained through inspection and just saying x times what here will be equal to x squared. It's x, right? Everything is positive, definitely that will be a plus. 2 times what here will give me a 2, that will be 1. Okay, and 2x plus x gives us 3x. So those are the factors of this expression or quadratic trinomial, right? Alternatively, you may have started with the positive 1 or the negative 1. You would have gotten to the same result. As long as you test carefully, ensure that when you plug in your values, you get to the right numerical value, and what you want obviously is a 0. That will make that a factor. So this takes care of case 1, all right? And what you can also do is the following. As part of your lessons, introduce connections. In which other topic do we use this? Okay, where do we use this? In other words, you can talk about a rectangle, right? This is a product of dimension. So in other words, you are asking, how do we quantify this result? What is the physical meaning of these factors? Okay, so we can look at the rectangle, right, and say, actually, this represents dimensions, where x plus 2 is our length and x plus 1 is our breadth. Okay, and the product of these dimensions represent for us what? What is that? Area of a rectangle, length times breadth. This is what you bring in here, length times breadth. Okay, not only that, it is also linked to optimization under calculus. So this really forms a build up to grade 12 mathematics when you get to optimization and you now generate the area formula of some polygon, x squared plus 3x plus 2. And there obviously we ask students to minimize, or maximize quantities such as area and things like that. So this is the links and connections that you can create, and actually this will make more sense to the students perhaps to know that actually what you're doing here is to find product of dimensions, physically speaking, or in a physical dimension where you want to quantify your answers and interpret the result. Okay, so in terms of area, that is what it can mean. In terms of optimization under calculus, that is what you are at, in terms of saying actually these factors are actually the area formula of some polygon that you are dealing with. It can be a form that takes a rectangular form, and somebody wants to plant things there, and you need to work with that. So yeah, this takes care of case 1. Let us go to case 2. Right, so let us go to case 2, where the coefficient of x squared, our leading term, is not 1. And as you can see, it's a 2 there, and our constant is 3. So what are we going to explore? The ratio of 3 over 2, plus or minus, as well as plus or minus 1. 1 is a factor of 3 and also a factor of 2. Let's start with the 1. If you plug in 1 there, definitely this won't be equal to 0. It will be a number greater than 0. If you plug in negative 1 there, Negative 1 squared is 1 times 2. 2 plus 3 is 5. Negative 1 goes there, it's minus 5. So 5 minus 5 is definitely 0. So if x is equal to negative 1, we have 2x squared plus 5x plus 3 equal to 0. The factor theorem then says that x plus 1 is a factor, right, of 2x squared plus 5x plus 3. We have obtained the first linear factor. The other one can be obtained through inspection, right? So we know that 2x squared plus 5x plus 3 is equal to x plus 1. Okay, what is the other linear factor? X times what here will give you 2x squared. It's 2x. It's the only option there because 2 is a prime number. Everything is positive, so this is a plus. 1 times what here will give you a positive 3. That will be 3. And 2x plus 3x will give you 5x. This represents the factors of the given quadratic trinomial. Great stuff. Let us go to case 3. Alright, case 3 has to do with the coefficient of x squared being negative or being a negative number. In this case, we have a negative x squared plus 5x plus 14, and we need to factorize this. Okay, so what do? The first step is to factor out that negative 1, and you end up with this, right? So the factor theorem will be applied to the expression that is inside the brackets, and we'll carry that negative sign as an outer term throughout. Okay, so what are we going to explore? Our ratio now is going to be 14 and 1, right? That is the coefficient of our leading term. So plus or minus 14, okay? Factors of 14 plus or minus 7, right? Plus or minus 1, okay? So basically that is where we are. Also plus or minus 2. Well, 2 is also a factor of 14. So let us start with the smaller numbers. If I start with 1, plug in 1 there. 1 minus 5, definitely that is not 0. Negative 1 also will not work, right? Let us go to 2. If I plug in 2 here, okay, so 2 squared, it's 4, right? And 4 minus 14 is a negative 10. And then if I plug in 2 here, I've got 2 times my negative 5 is negative 10, minus 10 is negative 20. That won't work as well. If I work with negative 2 though, okay, negative 2 squared is 4, right? And 4 minus 14 is negative 10. And negative 2 times negative 5 gives us a positive 10. So 10 minus 10, that will work, right? So if x is equal to negative 2, right, then we have x squared minus 5x minus 14 is equal to 0, which means that x plus 2 is a factor of x squared minus 5x minus 14. Okay, and what do? We write it like this. So this will come down here. It's equal to negative x plus 2. Okay, x times what here will give you x squared. That will be x. Okay, and we need to fix the signs now. This is negative 14. So 2 times what will give you negative 14? That is minus 7 there, right? And 2x minus 7x will give you minus 5x. That negative is still there. That will be your odd term. And that is how you deal with this case, all right? And this takes care of case 3. We're going to go to our last case now, where you can factor out a particular number is the highest common factor and apply the factor theorem there. Let's go for it. Right, so case 4, we are working with the situation where we take out the highest common factor first before we apply the factor theorem. So we have 2x squared minus 4x minus 16. Definitely 2 is your highest common factor there. This is equal to 2x squared minus 2x minus 8. Okay, 2 is our outer term here. So what are we going to do? We're going to explore the following. What happens when we have this ratio 8 over 1 plus or minus 8? Okay, factors of 8 plus or minus 4 plus or minus 2 plus or minus 1, and test each one to see which one works. The 1, okay, 1 minus 2 minus 8 don't work. The negative 1 will not work either. Okay, what about the 2? 2 squared is 4, right? Negative 2 times 2 gives us minus 4, 0, that disappears, don't work, right? What about the negative 2? Negative 2 squared is 4. Negative 2 times the negative 2 gives you 4. 4 plus 4 is 8, minus 8 is 0. So the negative 2 works. So if x is equal to negative 2, we have that x squared, okay, or this implies that x squared minus 2x minus 8 is equal to 0. So then x plus 2 is a factor of x squared minus 2x minus 8. What do? Bring this guy down, and this is equal to 2 times x plus 2. X times what will give you x squared? It's x. Let us check the signs. We want a minus 8. So 2 times minus 4 will give you minus 8 or negative 8, and 2x minus 4x will give you a negative 2x there. So this takes care of this case, which is our last case in this video, to represent the relationship between factor theorem and the process of factorizing, especially at grade 10 level. It's the fundamental grade for the FET. And as I said, you can always build connections using calculus, using area of polygons, and you can explore even the square of a binomial when you have x plus 3 all square, for example, and show the students that represents the dimensions of a square, where all sides are equal, x plus 3, and that can be the connection that you create there. And again, that speaks to area, isn't it? The area of polygons or two-dimensional shapes, and that speaks to calculus, optimization and minimization and maximization of quantities. So yeah, let us implement this strategy in the classroom and see how effective the lesson will be. Yes, there are many other methods like the cross method, the for method, but this is a fresh new perspective, but also a very important one to present, because it shows the connections that are necessary for mathematics in grade 11 and 12 when it comes to factorization, especially of functions of a higher order. So thank you very much for tuning in, and I wish you excellence in your classrooms. Shap shap.